corazón.
So, let we start our presentation with project objective. First, to acknowledge what volumetric analysis. Second, to understand the theory behind volumetric analysis. Third, to apply knowledge of chemical reaction and stoichiometry to perform titration or other volumetric analysis. And lastly, to accurately determine the concentration or amount of a substance in a solution using volumetric technique.
For an introduction, what is volumetric analysis? Volumetric analysis, also known as titrimetric analysis, is a method of quantitative chemical analysis used to determine the concentration of a solution by measuring the volume of a reactant of known concentration needed to react completely with the analyte. This technique relies on the principle of stoichiometry, which ensures that the reaction between the analyte and the titrant occurs in precisely determined proportion.
Next, we move to the theory of the volumetric analysis. The first one is titration principle. Volumetric analysis relies on the principle of neutralization or a chemical reaction between analyte and titrant. Next, equivalence point. This is the point during titration where the amount of titrant added is stoichiometrically equivalent to the amount of analyte present. At this point, a chemical reaction between the analyte and titrant is the third one is indicator. An indicator is used to signal the endpoint of the titration. It will change color when the equivalence point is reached, helping to accurately determine when the reaction is complete. The last one is types of titration. Volumetric analysis encompasses various types of titration methods, including acid-base titrations, precipitation titrations, complex isometric titrations, and redox titrations, and each suits for different types of analytes.
Example question of volumetric analysis. A 0.723 gram sample of chalk, largely calcium carbonate, was dissolved in 20 cm3 of 1 molar hydrochloric acid. When the reaction was complete, the remaining acid was titrated with 0.5 molar sodium hydroxide solution. The titer was 12 cm3. Assuming only the calcium carbonate reacts with the acid, what percentage of the chalk sample is calcium carbonate? So first, let's look at what is back titration. A back titration is a titration method where the concentration of an analyte is determined by reacting it with a known amount of excess reagent. The remaining excess reagent is then titrated with another second reagent. The second titration's result shows how much of the excess reagent was used in the first titration, thus allowing the original analyte's concentration to be calculated.
So, here we come to the methodology. First, measure a 0.723 gram sample of chalk with an analytical balance and transfer it into a clear beaker. Using a volumetric pipette, measure 20 cm3 of 1 molar hydrogen chloride and add it into the beaker containing the chalk sample. Gently swirl the mixture to ensure the chalk reacts completely with the acid. Allow the reaction to proceed until all the chalk has completely dissolved and no further reaction is observed. After the reaction is complete, the solution will contain unreacted hydrogen chloride. So, we need to titrate this remaining acid with sodium hydroxide. With the unreacted hydrogen chloride solution that you have prepared, Transfer it into conical flask and add 2 or 3 drops of phenolphthalein as indicator. Rinse the burette with a small volume of 0.5 molar sodium hydroxide solution. Then fill it with sodium hydroxide solution and record the initial reading. Titrate the hydrogen chloride in the conical flask with the sodium hydroxide from the burette slowly while shaking the flask until the indicator color change from colorless to a faint pink. Lastly, record the final volume of sodium hydroxide in the burette.
Next, I will explain about the calculation in this example. So, step 1, we have to find number of mole of initial HCl. 1 mole per liter times 20 times 10 negative 3 liter, and we get 0.02 mole of initial HCl. And next, we have to find mole of NaOH, which is 0.5 mole per liter times 12 times 10 negative 3 liter, and we get 6 times 10 negative 3 mole for NaOH. So, we have to use the ratio 1 mole HCl over 1 mole NaOH to find the mole excess HCl, and we get 6 times 10 to the power of negative 3 mole HCl. Next, we have to find the mole of HCl reacted by using the formula initial mole of HCl minus excess mole of HCl, which is we got 0.014 mole for HCl reacted. And then the mole of CaCO3 reacted, we are using the ratio 1 mole of CaCO3 equals to 2 mole of HCl and times with 0.014 mole of HCl, and we get 7 times 10 to the power of negative 3 mole CaCO3. And then we have to find the mass of CaCO3 reacted by times the 7 times 10 to the power of negative 3 mole times 100 gram per mole, and we get 0.7 gram. And the last one, we have to find the percentage of weight over weight CaCO3, which is 0.7 gram over 0.723 gram times 100%, and we got 96.82%. So the percentage of calcium carbonate in chalk sample is 96.82%.
So now I am going to continue with the conclusion part. In conclusion, the objectives previously discussed from us has been successfully achieved. So the first objective is we get to acknowledge the volumetric analysis. It is commonly known as titrimetric analysis. It is a quantitative chemical analysis technique. It measures the concentration of a solution. The approach determines the volume of a reactant at a known concentration. The reactant volume is used to fully react with the analyte. The stoichiometry serves as the foundation for the approach and the ensure that the reaction occurs in precisely defined quantities. Next, we are going to continue with the second objective. We get to know the theory of the volumetric analysis. The titration principle involves a chemical reaction between the analyte and titrant to neutralize it. Equivalent point occur when the amount of titrant added is stoichiometrically equal to the amount of the analyte present, indicating the chemical reaction is complete. When the titration reaches its endpoint, the indicator changes color to indicate equivalency. The titration type will include acid-base, precipitation, complexometric, and redox, each suitable for different analyte. After that, for the third objective, we get to conduct titration and other volumetric analysis by using the understanding of chemical process and stoichiometry. And the last objective that we have obtained is that we can properly determine the concentration or amount of a material in a solution using volumetric approaches. So, based on the question we have presented earlier, we need to calculate the proportion of calcium carbonate in the chalk sample, the percentage of calcium carbonate. So, based on the calculation we have shown, the chalk samples contain 96.82% of calcium carbonate in it.
Kan bangun tu.
Lama je kau tidur tu. Mimpi apa weh? Bangun.
Bangun. Wih.
Aduh, tidur pula.
Benda lah yang tidur ni. Buat kerja.